Question 1. The central argument for grounding in HVACR systems involves not only personnel protection but also equipment functionality. Consider a situation where a rooftop HVAC unit repeatedly fails during storms and electrical diagnostics reveal voltage fluctuations on its casing. What is the most probable grounding issue? A. The equipment is bonded but lacks the grounding electrode conductor. B. The unit is grounded through a ground rod only. C. The unit uses an isolated ground without connection to the system neutral. D. The system is overbonded at multiple points in the equipment. Answer. Correct answer. C. Explanation. An isolated ground without reference to the system neutral can cause elevated potential on metal parts during transient events. NEC 250.485 requires that metal parts be connected to the grounded conductor to ensure fault clearing. Voltage fluctuations on the casing suggest the equipment is not effectively referenced to the system ground, resulting in erratic fault paths and system instability during lightning or surge events. Question 2. Through careful analysis of fault current paths in HVACR systems, a technician notices a metallic condensate drain line creating a parallel return path for fault current. What should be done to mitigate the risk? A. Replace the metallic line with a non-metallic alternative. B. Install a GFCI breaker upstream. C. Bond the condensate line to the equipment grounding conductor. D. Add a separate grounding rod for the condensate system. Answer. Correct answer. C. Explanation. Per NEC 250.104 C. Any metal piping likely to become energized must be bonded to the equipment grounding conductor. This ensures a low impedance path back to the source and clears faults effectively, leaving metallic parts unbonded risks parallel current paths and shock hazard. Adding grounding rods deep without bonding can worsen voltage gradients and is not compliant. Question 3. When presented with a residential HVAC system that includes a variable frequency drive (VFD) controlling a blower motor, the technician observes nuisance tripping and harmonic distortion. Which grounding measure is most likely missing or inadequate? A. An isolated ground for the VFD with shielded cable. B. A dedicated bonding jumper to the main panel. C. A low impedance equipment grounding path with minimized loop area. D. Supplemental grounding rod installed at the motor location. Answer. Correct answer. C. Explanation. VFDs generate high-frequency noise and require a low-impedance ground path to reduce ME. NEC 250.102 and ESDD 1100 recommend minimizing ground loop area and using wide conductors or braided straps. Option C directly addresses this. Isolated grounds A can worsen high-frequency return paths, bonding jumpers and rods. B, D help, but don't address impedance and noise. Question 4. According to recent studies, improper equipment grounding in HVAC systems is a leading cause of undiagnosed compressor failures. Which of the following best explains why they ground loops prevent proper refrigerant cycling? B. Ungrounded systems can develop capacitive coupling, elevating casing voltage. C. Bonded systems lead to excessive amperage draw. D. Rounding reduces resistance in high voltage windings. Answer. Correct answer. B. Explanation. Ungrounded or poorly grounded equipment can accumulate stray voltage via capacitive coupling, especially in long runs or rich environments like HVAC. This voltage can damage compressor electronics or insulation. NEC 250.4A5 mandates effective grounding to eliminate such floating potentials. Ground loops, they are an ME issue, not directly linked to cycling. Question 5. In contrast to traditional single-point grounding, modern HVACR systems with multiple control panels often use interconnected bonding. What is the primary risk if these bond points are not coordinated? A. Overloading the transformer. B. Creating parallel fault paths and touch voltage differences. C. Delayed motor startup. D. Backfeeding the utility system. Answer. Correct answer. B. Explanation. Improperly bonded systems can have unequal ground potentials between points, causing dangerous touch voltages or stray current paths. NEC 250.96 and 250.102 C require bonding connections to be continuous and low impedance to prevent this. Overloaded transformers or delayed startup are secondary concerns. Utility backfeed is unrelated. Question 6. As illustrated by a case involving Mr. Derek, a field technician diagnosing erratic behavior in a rooftop HVAC system connected to multiple metallic support structures. Resistance testing reveals high ohmic readings between bonded components. What should Mr. Derek do first to ensure compliance and safety? A. Install additional ground rods. B. Check all mechanical bonding connections for corrosion or looseness. C. Replace bonding jumpers with high gauge wire. D. A surge protection device. Answer. Correct answer. B. Explanation. High resistance between bonded components typically indicates corroded or loose connections. NEC 250.92. B. Requires bonding to be continuous and effective. Simply adding more rods doesn't resolve internal bonding continuity. High gauge wire. C. May help, but only if the connections are mechanically and electrically sound. Surge protection. D. Addresses symptoms, not root causes. Question 7. Throughout the course of an inspection, a technician finds that a control panel for a split HVAC system lacks a direct bond between the enclosure and the grounding electrode conductor. What is the most serious potential hazard? A. Nuisance tripping. B. EMI from switching circuits. C. Inability to clear. A line-to-case fault. D. Intermittent compressor operation. Answer. Correct answer. C. Explanation. If the enclosure is not properly bonded to the grounding system, any line-to-case fault cannot return to the source to trip the overcurrent device, creating a shock hazard. NEC 250.4A3 and 250.96 mandate bonding all conductive enclosures to ensure rapid fault clearing. MEB may occur, but is not life-threatening. Compressor issues, D, are symptoms, not primary risks. Question 8. From a practical standpoint, grounding electrode conductors (GECs) for HVACR systems must meet which of the following key criteria for effective fault current return? A. Must be insulated and color-coded green. B. Must be connected only at the utility transformer. C. Must be continuous sized per NEC table 250.66 and terminate at the first means of disconnect. D. Must be paralleled with the grounded conductor in all subvalves. Answer. Correct answer. C. Explanation. The NEC 250.66 and 250.64 requires GECs to be sized based on service entrance conductor size and terminate at the grounding bus in the main service. Continuity is critical for fault current return. Color coding A applies to X, not GECs. Utility only grounding B is prohibited. Paralleling neutrals and grounds D beyond main panel violates 250.24A5. Question 9. Considering the evidence is Patel as troubleshooting a high-end HVAC system with multiple control panels interconnected via metallic conduits, she discovers that ground fault current from one panel is returning through control wiring instead of the conduit. What is the most likely cause? A. Control wiring is not shielded. B. The conduits are not properly bonded across junction points. C. Grounding electrode conductor is too long. D. Neutral is bonded at each control panel. Answer. Correct answer. B. Explanation. Metallic conduits must be bonded at all points to maintain a continuous fault path. NEC 250.96 and 300.10 mandate mechanical continuity and bonding of all metallic raceways. If bonding jumpers or lock nuts are missing or loose, fault current may find alternate unsafe return paths like control wiring. Bonding the neutral at subpoles D is violation but wouldn't explain the return path through control wiring. Question 10. In response to frequent service calls on an HVACR rooftop unit, a senior technician finds that bonding jumpers were installed using self-tapping screws. Why is this? A serious code violation. A. The screws may not allow sufficient torque. B. Self-tapping screws can be reused, which violates NEC reuse rules. C. A. Are not recognized as bonding methods per NEC. D. The screws can cause arcing due to magnetic interference. Answer. Correct answer. C. Explanation. Per NEC 250.8b, bonding Jumpers must be connected using listed pressure connectors or listed lugs. Self-tapping screws are explicitly disallowed because they may not maintain a reliable, low-impedance connection over time. This is a serious hazard, particularly in vibrating HVAC rooftop systems. Reusability or magnetic interference (BT) are not relevant concerns under NEC. Question 11. A new VRF variable refrigerant flow system is being installed in a high-rise building. The design includes isolated metallic refrigerant lines running between floors. During commissioning, technicians report tingle voltages near indoor units. What critical step was likely omitted? A. The refrigerant lines were not insulated properly. B. The refrigerant lines were not bonded to the building's grounding system. C. The system lacks a surge protective device on the control circuit. D. The refrigerant lines were run in parallel with power feeders. Answer. Correct answer. B. Explanation. Metallic piping that can become energized must be bonded per NEC 250.104. C. Without bonding, stray voltages can appear on refrigerant lines, creating a serious shock hazard, especially in systems with large interconnecting metallic components like ERF. This bonding provides a low impedance path back to the source and stabilizes voltage potential. Question 12. While assessing a backup generator system feeding an HVAC panel, you find the neutral is bonded to ground at both the service entrance and at the generator panel. What hazard does this create? A. Voltage imbalance between phases. B. Ground loop currents and parallel neutral paths. C. Excessive transformer heating. D. Reduced GFCI sensitivity. Answer. Correct answer. B. Explanation. Bonding neutral to ground at multiple points creates parallel return paths through grounding conductors and metallic raceways. This can result in circulating ground loop currents, elevated voltage gradients, and possible tripping of overcurrent protection. NEC 250.2485 permits neutral to ground bonding at one location only, typically at the main service. Question 13. An HVAC unit installed on a metal catwalk is exhibiting unusual electromagnetic interference with nearby control wiring. All power and signal wiring is correctly installed in metallic conduit. What grounding improvement could best resolve this? A. Add ferric beads to all power cables. B. Increase the length of the ground path to isolate the interference. C. Bond the metallic catwalk to the building grounding system. D. Install a separate ground rod at the catwalk location. Answer. Correct answer. C. Explanation. Unbonded metallic structures like catwalks can act as antennas or alternate return paths for ME. NEC 250.104a requires bonding of structural steel that is likely to become energized. Proper bonding reduces voltage differences and helps shield sensitive systems by creating a common grounding reference. Question 14. In a fault simulation test, an HVAC technician observes that the breaker does not trip when a ground fault is applied to the metal frame of the air handler. What is the most likely cause? A. Grounding electrode resistance exceeds 25 ohms. B. The equipment grounding conductor is disconnected. C. The neutral conductor is undersized. D. The overcurrent device is rated too high. Answer. Correct answer. B. Explanation. If the equipment grounding conductor EC is broken or disconnected, fault current cannot return to the source, so the overcurrent device doesn't trip. NEC 250.4a3 emphasizes that the EC must provide low impedance path for fault clearing. Ground resistance A matters for lightning, but not for clearing faults. Question 15. During an audit of a multi-zone HVAC control system, multiple subpanels in the building were found to have the grounded neutral conductor bonded to the enclosure. What is the recommended corrective action? A. Disconnect the equipment ground conductors. B. Add isolation transformers at each subpanel. C. Remove the neutral to case bonds in all subpanels. D. Replace the panel boards with ones rated for isolated ground. Answer. Correct answer. C. Explanation. Per NEC 250.2485, the neutral to ground bond must be made only at the main service disconnect in subpanels. This bond must be omitted to avoid parallel return paths and circulating currents on the EC. Leaving the bond in place can create shock hazards and improper fault clearing behavior. Question 16. While upgrading the main HVAC disconnect, the grounding electrode conductor GEC was found spliced inside a metal junction box using wire nuts. Which neck violation is most relevant here? A. The GEC must not be spliced under any condition. B. Wire nuts are not an approved method for splicing GECs. C. The splice must be made outside the building. D. A junction box cannot contain grounding conductors. Answer. Correct answer. B. Explanation. Per NEC 250.64 C. Grounding electrode conductors may be spliced only by reversible compression type connectors or exothermic welding. Wire nuts are not approved for this critical conductor as they may fail over time and compromise fault current return capability. Splicing is permitted, but only using listed permanent methods. Question 17. While inspecting an HVAC rooftop installation, you discover a supplemental ground rod has been installed and connected to the metal casing of a condensing unit without any connection to the main service grounding system. What is the primary risk of this setup? A. Overvoltage to the compressor windings. B. Fault current may not return to the source to trip the breaker. C. Transformer backfeed into the ground rod. D. Lightning current will energize control circuits. Answer. Correct answer. B. Explanation. A ground rod without a connection to the system ground does not complete a return path for fault current. NEC 250.54 allows supplemental grounding electrodes only when bonded back to the grounding system. Without this, the breaker may not trip in a fault, leaving metal parts energized. Question 18. A building engineer reports nuisance tripping of offside devices on circuits supplying HVAC zone dampers with control transformers. What grounding configuration is most likely contributing to this? A. Separate ground rods used for each transformer. B. Equipment grounding conductor and neutral conductor share the same raceway. C. The control transformers have bonded neutrals in each zone. D. Shielded cable used for all low voltage wiring. Answer. Correct answer. C. Explanation. If control transformers in different zones bond their secondary neutrals to ground, this can create multiple return paths and circulating currents. Offside devices detect this as a fault. NEC 250.38.1 requires a single point of bonding for separately derived systems to avoid such issues. Question 19. A technician finds that HVAC control wiring enclosed in flexible metallic conduit is picking up stray voltage. A clamp-on ammeter shows current on the conduit. What is the most probable cause? A. A disconnected equipment ground at the panel. B. A failed insulation layer in the thermostat wiring. C. The conduit is acting as an unintended return path due to bonding failure. D. Voltage drop in low voltage control wiring. Answer. Correct answer. C. Explanation. Stray current on a metallic conduit often indicates a failed bonding connection, causing the conduit to unintentionally carry return current. NEC 250.96 and 300.10 require proper bonding to ensure metallic raceways do not become energized or act as unintended current paths. This is a serious shock hazard and can damage controls. Question 20. In a large HVAC system powered through a transformer, a technician notices the grounding electrode conductor from the transformer is connected to a cold water pipe with no supplemental electrode. What's the most accurate code-based assessment? A. This setup is compliant since the cold water pipe is metallic. B. Supplemental electrode is required if the cold water pipe is used as the sole electrode. C. The cold water pipe must be replaced with driven rod. D. Transformers do not require grounding electrodes. Answer. Correct answer. B. Explanation. Per NEC 250.52.8.1 and 250.53 D2, if a metallic cold water pipe is used as a grounding electrode, a supplemental electrode G. Ground rod must also be installed and connected. This ensures redundancy and long-term stability of the grounding system. Cold water pipes alone are not sufficient. Question 21. An HVAC contractor installs a new air handler on the second floor of a commercial building. The installer bonds the equipment to a nearby building's steel beam but fails to verify the beam's connection to the grounding electrode system weighs the most significant risk. A. The system will not be GFCI compliant. B. The beam may energize during fault and remain live. C. Lightning protection systems will be compromised. D. Overcurrent protection will trip prematurely. Answer. Correct answer. B. Explanation. Per NEC 250.104a, bonding must ensure that low impedance fault path back to the source. If building steel is used but not properly connected to the grounding electrode system, a fault can energize the steel without tripping breakers, creating electrocution hazards. Question 22. During an HVAC rooftop unit inspection, you find that the flexible metal conduit FMC connecting the unit to the junction box lacks a separate equipment grounding conductor. Which of the following would most influence whether this is compliant? A. Whether the circuit is GSEI protected. B. Whether the conduit is 6 feet or shorter. C. Whether the conduit is labeled liquid type. D. Whether the conduit has listed ground path rating. Answer. Correct answer. D. Explanation. Per NEC 250.118.5, FMC may serve as an EC only if it is listed and marked for grounding and properly installed with fittings that ensure continuity. Many FMC types do not meet this without a separate EC. The 6-foot rule. B. Applies to exceptions, but only if the type is compliant. Question 23. An HVAC technician installs a grounding electrode conductor GEC for a new panel serving a variable frequency drive (VFD). They route it in a metallic raceway and bond the raceway at both ends. What NEC issue does this create? A. Electromagnetic induction from the VFD will overload the GEC. B. The metallic raceway creates a prohibited parallel ground path. C. Bonding both ends violates single-point grounding rules. D. The GEC must remain unbonded if inside metallic conduit. Answer. Correct answer. B. Explanation. NEC 250.64a prohibits metallic raceways containing GECs from being bonded at both ends, as this creates parallel paths for fault current which can interfere with grounding system operation and introduce noise, especially in NEFDS. Question 24. While inspecting a rooftop HVAC installation, you find that the ground rod has been driven and bonded to the unit, but not to any other part of the building's grounding system. What critical NEC section is violated here? A. 250.30 B. 250.66 C. 250.54 D. 250.58. Answer. Correct answer. An explanation. Per NEC 250.30 C, grounding electrodes installed for separately derived systems must be bonded back to the building grounding electrode system. Installing a ground rod alone at rooftop HVAC equipment without this bond creates a floating electrode which won't clear faults. Question 25. An HVAC electrical inspection reveals a multi-speed air handler where each speed tap is powered via separate relays from a 400 ATIV supply. The metal frame is grounded but not bonded to the panel board. What condition exists? A. No hazard as the frame is already grounded. B. A risk of short cycling between speed taps. C. The frame may not clear. A fault if it becomes energized. D. Voltage imbalance across the blower motor. Answer. Correct answer. C. Explanation. Grounding alone is insufficient. The bonding connection ensures a low impedance path back to the source. Without bonding to the panel board or any fault current may not return, preventing overcurrent protection from tripping. This violates NEC 250.485 and 250.96. Question 26. An HVAC installer runs control circuits in end conduit across multiple rooms. The metallic conduit is not connected to ground at either end. Which of the following is the most likely hazard? A. Ground loop formation. B. Voltage transient injection. C. Unintentional capacitive coupling. D. The conduit may become energized and remain live. Answer. Correct answer. D. Explanation. per NEC 250.86 and 250.96 say all metallic raceways must be bonded to ground. Leaving both ends unbonded risks the conduit becoming energized via fault or induction, posing shock and fire hazards. This also impairs circuit protection from working properly. Question 27. In a new chiller installation, the grounding electrode conductor is connected to rebar embedded in concrete without verifying continuity to the building's main grounding system. Which NEC rule governs this oversight? A. 250.50b, 250.52a3, C. 250.53b, D. 250.68, C1. Answer. Correct answer. D. Explanation. Per NEC 250.68 C1, concrete encased electrodes, U for grounds, must be electrically continuous with the rest of the grounding electrode system. Not verifying the rebar's connection to the grounding system is a critical omission that could cause ineffective fault clearing. Question 20. An HVAC zone control panel with several transformers is being installed in a hospital. The engineer requires all grounding conductors to be isolated from building ground except at the main panel. YA. To increase voltage output at the transformers. B. To prevent electromagnetic interference in ground loop. C. To reduce current draw and transformer heat. D. To comply with NEC 517 hospital-specific grounding exemptions. Answer. Correct answer. B. Explanation. Isolated ground systems help prevent ground loops and ME, which can affect sensitive hospital equipment. NEC 250.146d permits use of isolated grounds in certain environments. Transformers should have a single bonding point to prevent circulating currents from multiple paths. Question 29. The technician measures 17 potential between bonded metal piping and the panel board enclosure in an HVAC mechanical room. No voltage should exist. Which is the most likely cause? A. Capacitive coupling from nearby transformers. B. A broken neutral or improper neutral to ground bond. C. Incorrectly phased lighting circuits nearby. D. Static buildup from motor startup. Answer. Correct answer. B. Explanation. The missing or poor neutral to ground bond or an open neutral can result in stray voltage on bonded metallic parts. NEC 250.24a5 requires bonding a single point, and improper or missing bonding can allow voltage differentials between grounded components. Question 30. A rooftop unit experiences repeated contactor coil failures. Voltage measurements reveal line to ground voltage fluctuations during motor startup. What grounding correction would best resolve this? A. Bonding the unit casing to a dedicated ground rod only. B. Installing a surge protector on the motor starter. C. Connecting the unit to the building's AC using low impedance path. D. Increasing the overcurrent protection size. Answer. Correct answer. C. Explanation. A high impedance equipment grounding path can result in voltage transients during high inrush events like motor starts. NEC 250.4a3 mandates a low impedance fault return path to minimize voltage instability and equipment damage. A ground rod alone won't fix this.